hissed at you, and so on and so forth. So basically, you need to have a mechanism that bypasses the approval stage, but at the same time ensures only revert is possible. The approval is there for a reason, to catch code and bugs. So it should not be the case that when you revert, you add more bugs. So only revert should be like without approval. I mean, that also depends on case by case basis, but there should be revert mechanisms that can bring back your system within half a minute at the most. Next is adding observability. Now this is like a very dense topic, so which is like extremely important in distributed environments that we are going into. So observability basically means knowing what your application is doing at a high level, at a low level, at an average level, at a like historical level, etc., without actually interacting with it. Like, you should have a like bird's eye view of what the application is doing outside of the application. Now, an example would be how many requests your application is handling per second. You need to know this number. So this number is very critical, because if your application is serving 1,000,000 customers and your request per second drops to 10 requests per second, then we are gonna get a lot of timeouts on this client side. Basically, the application will be unusable for even the ones that get their request served. So you need to have a mechanism to observe that and notify you in case that drops. You need to know if the latency between the nodes of your distributed system is increasing, if the error rate of your third-party integrations is increasing. So this happens sometimes when this case happens when your third-party provider, any provider, they change the API on you. They just randomly change it. It happens. Even though they are not supposed to change public-facing APIs, they randomly sometimes do change the APIs. So you need to know, you need to track all these metrics and have alerting mechanisms. So whenever that fails. Now, I will tell you from experience that adding an observability framework after the fact is way harder than designing it into the system. So when you're designing a system, you should keep in mind that, oh, by the way, I don't mean logging. Logging is observability, but for logging, you have to be in the system to see the logs. I mean a dashboard which you can visually see where the error is. So observability is a very critical component on designing the system. Next is enforcing documentation. Now, a lot of us, including me, don't like writing documentation, but documentation doesn't have to be big. Documentation just has to explain what the code is doing without, without being so verbose that the developers don't feel like writing it. So in documentation, you can enforce documentation by the similar technique like enforcing the coding standards. You can basically just say all functions needs comments on what the function does. So if I had done that in the beginning, so I would have been able to easily pass on the code to somebody else. They would be able to figure out what they do, what they need to do for their part of code. So if you don't have documentation, what the thing happens is, as a designer, you know everything, and others, as they didn't touch anything, they don't know everything. So they will come to you for each and every minor doubt, which would have taken maybe like 1 minute, 2 minutes of your time to figure out. Thing is, it would take them 20 minutes to figure out the same thing that you did in 1 minute, because they don't have the entire context of the code. So adding documentation, like enforcing the documentation requirements, is critical